Now, as technology improves, project management software also improves. And we can use project management software to help us with constrained scheduling, as this example shows. So in this example, we have an EMR project where we're developing a handheld electronic medical reference guide. The problem is that we only have 8 design engineers who can be assigned to this project due to commitments to other projects and a shortage of design engineers. So when we look at how this would happen in a computer project, we have our project network view schedule before the resources are leveled and how many project engineers or design engineers we need at any given time. So what we find is that there's actually a period of time where we need 21 engineers. We have the project planned for 45 days. We have our task, our critical task, what Slack is available, and the entire summary of the schedule. We then put in the requirements for our design engineers. How many hours do we have design engineers available? How many hours does each project need them? And what time that those activities come into place? We run into our resource loading, and what we find is that we're over allocated for design engineers over the project. So we have to redo our schedule as we're leveling our project. So we have 8 design engineers available. There were activities scheduled in our project that needed 21 design engineers, and we had to level out that resource allocation to the fact that we only had 8 available and not 21. Now, we did increase the duration of this project. So we see here it's been increased to 57 days, where if we go back to the original screen, the duration was 45 days. Because of our resource constraint and the number of engineers available, we've had to increase the length of this project to 57 days. We can see here that we've leveled out how many engineers we need for each task so that we're only using 8 at any given time. The impacts of resource-constrained scheduling are that we first reduce slack, which reduces flexibility and increases how many critical events we have in our path. It also increases the complexity of our scheduling. So we make our project network plan based on a time constraint, early start and late finish. And then once we start scheduling resources, we add complexity to that scheduling. We might make the critical path no longer meaningful. We might have to break the sequence of events. So as you saw in one of the examples, we had to wait to start activity 2 until activity 3 was already finished because of a constraint. We can cause parallel activities to no longer be able to happen parallel. Then they become sequential because we don't have enough people to do them at the same time. There can be splitting of activities. It is not recommended, but it is understood that when we have constraints on a resource, that we might have to start working on another project or another activity while we're waiting for the resource to finish what they're doing. This is only feasible when startup and shutdown costs are low, but splitting of activities and multitasking is considered one of the biggest reasons for projects failing to meet their schedule. And a lot of the time is because when we multitask or when we flip from one project to another, there's a certain amount of startup and shutdown required, even mentally. Even if I don't think I'm moving from one task to another, I have to shift my thinking for that. So even if they're not obvious costs, there's still a mental start down and shut down every time we move from one project to another. When we talk about splitting activities, an activity duration without splitting is so many days. Now, if we split it into 3 segments, we add this duration of shutdown and startup. So we have to close out of activity A and get ready to work on activity B. We work on activity B for a little bit, and then we have to shut that down, move over, close our browser, move into something else, and start up with activity C. Splitting activities almost always adds time to projects. The benefits of pre-scheduling our resources is that it tells us when we might need to, when we're going to have constraints on our resources. It allows us to plan for that and to manage our project planning ahead of time. It gives us information for any time-phased work that we have to do. It helps us prevent any unforeseen events. Something that we might also have to look at is like what the cost time trade-offs are. So if we have a very time constrained project, but we're also resource constrained, is there a possibility that we're willing to go over costs to add additional resources to make that time constraint? Or are we more willing to go over the time constraint in an effort to reduce the amount of costs? When we're assigning project work, often we're not just assigning one project at a time. Most companies have multiple projects running at the same time, overlapping and using the same exact resources. So scheduling is much more complicated than even this chapter introduces. Why should we not always assign the best people to our most difficult tasks? So when the book talks about when we're choosing the people to work on our project, if we always choose the people who are best at it, the most difficult tasks, those best people will start to resent that they're always given the toughest assignment. And at the same time, any less experienced people will start to resent the fact that they're never given the opportunity to expand their skills. So it's easier to find ways to get veterans to work with new hires. If you can, instead of hiring 2 people who are the best at what they're doing, and instead get one of your best people and one of your less experienced people so that there's a mentorship and a learning relationship available if you have that availability to you in your resource scheduling. Another factor to consider when you're pairing people up in a project work is what skills complement each other. What kind of things work well together? For example, my husband is a web developer and he works on a project team for web development and he writes code. And one of his coworkers, he says, is really, really good at taking code and making it pretty. So he'll make the website functional, but then his coworker knows how to take that functional item and make it attractive for what the client is looking for in a website view. So their work complements each other. As I said earlier, most of the time we are scheduling for multi-projects. When we have overall project slippage, we can delay multiple projects. So for example, if we only have 8 design engineers, so we're looking at in that computer scheduled example, we have 8 design engineers and they're all working at that one project at the exact same time. If there is another project that needs 2 design engineers and the first project is delayed for any reason, then the other project gets delayed. And this could be multiple projects that end up getting delayed. We can also have inefficient resource allocation. We don't always control when those peaks and valleys of resource demands are. We might have high demand in seasonal times and low demand in the off season. When we have high demand and a shortage of resources, we get bottlenecks. Bottlenecks create time delays. So when we have multiple projects that are trying to use the same exact resource, we get time delays and we have to extend our schedule. The only other option of fixing a resource bottleneck without a time delay is to increase the number of resources we have at that bottleneck. Whether we're able to hire more people with that skill set, buy extra equipment. If we're extremely financially limited, then we just have to find ways to get through the schedule issues with that resource bottleneck. When one of the options for managing multi-project scheduling is to create a position or department that does nothing but resource allocation for projects. We would use the project priority queuing system. You can use first come, first serve for resources, or you can schedule projects that are priority. You can schedule based on Slack or based on time consumption, get the shortest projects done first. Will we draw up the ones that have less time pressing? One of the suggestions is to treat everything you're doing as part of one central mega project instead of doing individual project management. And you can, if you have the financial resources available, you can outsource projects to reduce the number of projects that you're handling internally. When we're using a time-phased budget baseline, why we would use a time-phased budget baseline is to determine if our project is on, ahead, or behind schedule and compare whether it is over or under its budgeted cost. We're going to be looking at in future chapters about performance evaluation during and at the end of the project. So often we want project updates. If we say that a project is going to cost $10,000 and take 10 weeks, we don't want to say that we're allocating $1,000 a week in costs, because the truth is we might have an area where we have 2 or 3 activities happening at once in 1 week. That week is going to have a higher resource allocation than any other weeks. So if we are at week 3 and we're already spent $7,000 of that project, we might say, wait a second, we had budgeted $1,000 a week for this project. Why are we already at $7,000 in week 3? We're going to go way over budget. That isn't necessarily the case, which is why we want this time-phased budget baseline where we put costs along with our WBS and our project network. So we would assign each work package to a department and deliverable and compare those plans, schedules, and costs using an integrative system. So we have this example from chapter 4 brought back over where we were looking at a computer application. And we have the different costs for that. So our total budget then for the work package and for our cost account and what times those get assigned. So we want to look at when we're on project, we don't want to say how much did we spend in week 1 or how much did we spend in week 2. We want to make sure that each activity has a cost and we're looking at how those activities are progressing. This time phase budget, then, we can see we have different costs in different weeks. We have a total projected labor cost of $120,000, which is going to be spread over the first 3 weeks of this activity. Then as we add activities, we can see that once we move to the second work package, which is integration, we in work periods 3 and 4, then we add additional costs. We have a project network plan here, and we're going to look at this project network plan as it gets assigned to its time-phased work packages. Once we have these time-phased work packages, then we're going to assign its budget costs. So now we have a project monthly cash flow statement that has been assigned based on the project's actual project network and not its total cost and total duration. But instead we're looking at what work is being done at what time and how much does that cost occur. We then can use that monthly information from here to go to a weekly resource usage schedule. And that is the end of chapter 8.